Pineapple coconut, white chocolate,
Okay.
And I'm just going to stop. Hey, how are you?
Good, how are you?
You're usually weird on the screen.
Or maybe this is his or someone else's. What looks weird on the screen?
So this is the SAAG session. We're starting in a second. If you want to take your seats. Make it?
The presentation.
Oh, so I can't actually see it from here on mirror screens.
I'm sorry that I wasn't here earlier.
Oh, yeah.
Managing Sisters Plus a Baby. I'll start the sheets. Let me write on them.
Good enough? Is that doable?
You sure?
Yeah.
You're 1R, right?
Pardon?
You're 1R?
No, 2 hours. 2 hours.
I should know this by now.
Nice. So this is the SAAG security area open meeting. Please take your seats and silence yourselves. Folks, can you take your seats, please? Thank you. So you can take my phone out of it. Okay, so this is the Security Area Advisory Group. I'm Stephen. This is Kathleen.
Hello.
There is a notewell, which you've now read. Here's our agenda. So we have the usual, folks, if you want to keep talking amongst yourselves, outside the room is better, please. Thank you. Okay. Here's our normal agenda and agenda bash time. Anybody want to bash the agenda? Nope. Okay, so we have the usual thing with the reports. ABFAB, no meeting, no report. Should be, is Leif there? No. So ABFAB is, they have one document left, and I chatted with the chair, and if they finish it, great. Otherwise, we'll close them, and then they won't finish it. Ace, did you send a report? Acme?
I think so.
Did Acme send a report? Thank you. Jose? Yes. Curdle did it too. Dane didn't, I don't think was not meeting. Dots?
Yes.
HPOF did. I2NSF did. IPsec, yeah. Jose? Thank you. Kitten, yes. Lamps. Hasn't happened yet, but is Russ in the room? So Lamps is a new working group. It's looking at sort of some minor changes and maintenance kind of stuff for PKIX and SMIME with a very tightly scoped charter. And the intent is to keep the charter tightly scoped always. Mile. Yep. OAuth. Tell us what happened. So I just got the TNT presentation.
We had 2 meetings this week, and we started working group last call on 2 documents. One is the Native Apps Best Current Practice document, which you should pay attention to because it's the way how native or OAuth is built on native clients on smartphones, tablets, and other operating systems. We also had, at least from the participants in the room, good feedback on adopting the work of token binding for OAuth. We had some discussions on other security aspects, couldn't make some resolutions there. We need to put that back on the mailing list. So.
Okay, thank you. Thanks for sending the report when you do. OpenPGP did, SACM. Thank you. TLS, Tuckbind. Go to the microphone. Punishment time.
Hi, Leif Johansson, Token Mining. So we had one meeting today. We're trying to wrap up, and we believe the documents are almost there. There may be some minor language clarification around the API guidance, but more or less done.
Okay. Trans sent one, right? I know you didn't meet, but did you send a report? Nothing happened. Okay. Okay, so the list of related things, I think Kenny sent them for CF4G already, and is Ted or somebody here to talk about the IIB program? Turns out not. So the IIB have a security and privacy program, and we've gotten them to start sending reports like the...
Yeah,
yes,
he actually
oh, there you go.
no, he sent the report, though.
He did send a report, but since it's the first time, I thought, why don't you explain what the program does?
It's in the report. So the IAB has a privacy and security program. You can review the program page on the IAB programs page. It's currently working on a WebPKI document, some mitigations documents, and some stuff around, what was the last thing? I just lost it. It's out of my head.
Identifiers.
Identifiers, thank you. But it was, anyway, it's in the report.
Okay. Paul.
Two brief ones. Debound is probably never going to meet. We decided, or on the mailing list, it was decided that that there was not enough agreement. There was going to be an informal group meeting this week, and that didn't happen. And Deprive didn't meet this time, but we've seen in other working groups a fair amount of implementation work, implementation status work where there's being very good interoperability.
And does anybody want to tell us about any of these other working groups if there's interesting security happenings this week? Nobody today? Okay. So we had one buff. Jaron sent a report. Presentations. So first we have Karen and Tibor. And I will have to find which one it is.
So, Tibor, are you? Oh, there you are. Okay. So I actually don't have a slide. All I really wanted to do was introduce Tibor and explain the context of this. The Network and Distributed System Security Symposiums held in February each year. It's a academic security program, and this year we had a Tron workshop, TLS Ready or Not. The purpose of this workshop was to bring together academic researchers with a specific group of people that were that are working on the protocol development. We had a very successful workshop, and part of the reason why and Tibor is going to tell you a little bit about his research, but my ask for all of you all is, are there other opportunities? You know, what is the next place where we have a protocol where we really want security people to take a quick look at it? And I want you all to think about that and send suggestions. Yes?
Hi, this is Hannes. We had an OWASP workshop last week in the similar style as you had it. OWASP security workshop. OWASP security workshop, right. So this is what I'm interested in is specifically workshop ideas. There is a call for workshops that's out for NDSS and what might be the right context for that. So without further ado, I'd like to introduce Tibor Jaeger from Rouen University to talk about, he was selected as our very fancy name, best contribution to the IETF at that workshop, award winner. And part of that was we invited him here to the IETF to meet all of you all and see how the IETF works.
Bear with me. That's your one?
Yeah, so first of all, thanks for the introduction. thanks also for awarding us. So this was very encouraging for my co-authors, Juraj Somorowski, Jörg Schwenk from Ruhr University, and myself. And yes, so I would like to talk about the security of TLS 1.3 against weaknesses in a PKCS1 version 1.5 encryption scheme. This is a research result that we have presented last year at the ACM CCS conference, which is one of the 4 large security conferences in the academic world. Okay, next slide, please. Okay, what we should keep in mind throughout this talk are 2 facts that I want to kind of point out or remind you of. The first one is that the current version of TLS is version 1.2. So as you all might know, version 1.3 is currently under development, but this does not mean that everybody is using this most recent version. Yeah? The most widely used version is TLS 1.0, which is from 1999. So it's about as old as Windows 98 second edition. And I guess nobody would seriously consider using Windows 98 in a productive environment today, but we are all using TLS 1.0 today, every day, on nearly 100% of the server surveyed by SSL Labs. Next slide, please. So I do not want to go too much into the details of RSA PKCS1 version 1.5 encryption. One reason is that I do not want to repeat this name over and over again because it's relatively complex. Just briefly, RSA PKCS1 encryption is the most widely used mechanism to transport a key from a client to a server when a TLS connection is initially set up. And it was used in all TLS versions up to 1.2. In TLS, it is deprecated, so it's not used anymore. And I guess many cryptographers will agree that this is finally the right decision, and many people have been waiting for this for a long time. And one reason why it's a good decision to deprecate PKCS1 in TLS 1.3 is that it doesn't provide forward secrecy. But a second important reason is that this encryption scheme is vulnerable to attacks, like most importantly Bleichenbach's attacks, and it's extremely difficult to implement securely against all these attacks. The natural question that we looked at in this work is now, is it sufficient to remove PKCS1 encryption from TLS 1.3 in order to protect against its weaknesses? There is a seemingly obvious answer, and the answer is yes, of course, it must be secure because it doesn't use this encryption scheme, but it turns out that this belief is false, somewhat surprisingly. Next slide, please. So first of all, how relevant is Bleichenbach's attack? Again, I do not want to go too much into detail here, but I want to show that there have been many publications over the last years which kind of always find new tweaks or new techniques to mount or remount the original attack from 1998 from Bleichenbach over and over again in absolutely or in completely different applications and settings. Yeah? Most of these papers here on this slide attack one or the other TLS versions, but there are also other applications like EMV, key establishment, Europay, MasterCard, Visa, XML encryption, and so on. The most popular and probably currently most important example is the famous drone attack that you might have heard about, which was kind of announced earlier this year and which is going to be presented by Nimrod Aviram and his co-authors at the Usenik Security Symposium in mid of August, I think. So this constant stream of publications which kind of allow to apply variants of this original Bleichenbach attack over and over again gives no reason to assume that this stream of papers is going to end very soon or so. So it makes sense to analyze the security of cryptographic protocols under the assumption that such attacks will remain a realistic threat for protocols and encryption schemes in the future. Next, please. So how will TLS 1.3 be typically used in practice? So here's an example. First of all, we have one web server, and the web server implements at least two different versions of TLS. One is the up-to-date version 1.3, the most current version, and second is any old version which is used for backwards compatibility reasons, such as TLS 1.0, for example. And on this slide here, the server uses the same RSA certificate and in particular the same RSA public key for both cipher suites. This will be very important for our attack. And this is a standard deployment setting, and I will comment on this later in more detail. And then we have two different types of users. One type of users are like Lisa Simpson, so she's very smart, and she uses only the most recent state-of-the-art crypto algorithms because she's aware of Bleichenbacher's attack and all these bad things that can happen there. And there are other users like Ralph, and Ralph is not as smart as Lisa, so he uses this old, outdated TLS version 1.0. And by our assumption that these Bleichenbacher-like attacks may appear over and over again, we may assume that at least Ralph's connections may become insecure at some point in the future, but at least Lisa, who uses only and exclusively the most state-of-the-art crypto, may expect that her connections are secure. It turns out that this belief is false. Okay. So next, please. And here's how the attack works. So the attack is a man-in-the-middle attack, which means that the attacker controls basically the network, so it is able to inject arbitrary messages and drop messages. So what the attacker does is the following: when Lisa initiates her TLS 1.3 connections, so she sends a client hello and a client key share message, then the attacker responds as if the server would have responded. So it sends a server hello message, server key share message, and the certificate message. And this is easily possible for the attacker because all these messages are independent of the long-term secret of the server. So anyone can kind of compute and send these messages. The next message that the attacker has to send is the certificate verify message. And this is an important message which essentially contains a digital signature over all previously sent messages. And this is the kind of the authentication or the important authentication step in the TLS handshake. And in order to compute this message, the attacker would have to know the secret key of the server. So in principle, it should not be possible to compute this message. But by performing Bleichenbacher's attack against the old TLS version, TLS 1.0, it is able to forge the required signature. Okay, again, I do not want to go too much into detail here. So what the attacker does in principle is it leverages the weakness of the old version in order to compute the certificate verify message for the new protocol version. Okay, and this is possible. Finally, there are two more messages: server finished and client finished, and these are again independent of the server's long-term secret. So yeah, finally the attacker has successfully mounted a man-in-the-middle attack against the TLS 1.3 connection attempt of Lisa. So this shows that even though Lisa does not even use PKCS1 version 1.5 encryption, she's still vulnerable to attacks against this encryption scheme, which is somewhat surprising and which should be considered, I guess, in the design of protocols. Next slide, please. So how relevant is this attack? Well, most examples of Bleichenbacher's attack tend to be relatively, let me say, impractical. Because such attacks usually take around, in the order of several hours to several days, or maybe even weeks. And this is maybe a bit too slow to lead to practical attacks against browsers, against users sitting in front of a browser and waiting for a connection to be established. But every now and then, examples appear where such Bleichenbacher-like attacks are very practical. And again, the most recent and currently most important example is the Brown attack by Alviram et al., who showed that it's possible to forge the required signature and the cert verify message in a single minute on a single CPU, so without special purpose high performance hardware or so, by leveraging several weaknesses that occurred in OpenSSL, in all OpenSSL versions from 1998 up to early 2015. So this is really I guess this counts really as a practical and valid attack. And according to the paper by Nimrod Alviram et al., about 26% of the HTTPS servers on the internet were vulnerable to this attack. Yeah, next please. So how can we prevent this attack? And this is the aspect of this attack that I personally found most interesting, because the attack itself is relatively simple, but it turns out that it's extremely difficult to prevent, at least with the tools that we currently have on the internet. So there's one natural solution, which is called key separation. And key separation means that we use separate keys for separate protocols, separate protocol versions, separate algorithms, and so on and so on. And if you want to employ this technique, then we can try to do this by having two server certificates at the web server. One is the green certificate, which is assigned to TLS version 1.3. And the second one is the red certificate, which is assigned to TLS 1.0. And now we may hope that this protects Lisa against this backwards compatibility attack that I've just described. Since Lisa accepts only the green certificate, which belongs to the new TLS version 1.3, and this makes the vulnerability of the old TLS version, which uses a different set of certificate and a different key, useless. Okay, this is the intuition, how we might hope to protect against such attacks. Unfortunately, this doesn't work. So next slide, please. And the reason is that X509 certificates do not contain any version about the protocol or any information about the protocol version or the algorithms that they should be used with, which means that the attacker is simply able to present Lisa the old certificate, the red one, which belongs to a TLS 1.0, and is able to mount the same attack as before. So one issue that we have is that certificates do not contain any information about protocol version. So Lisa has no way of telling whether the certificate that she has received belongs to the TLS 1.3 implementation of the server or to the TLS 1.0 implementation of the server. Next slide, please. So this is only one of among several further difficulties. Let me start with the second one. So actually, there is a possibility to kind of to achieve some weak form of key separation in X509. And this is because X509 supports to distinguish between sign-only certificates and encrypt-only certificates. And this would at least have prevented the attack that I've described in this talk here. So this cross-protocol attack between TLS 1.0 and TLS 1.3. However, this makes only sense if, on the one hand, browsers support this. And at the Tron workshop, I talked to at least one browser developer who told me, well, okay, we know that there is this possibility, but we do not check it because it will kind of break user experience and usability. So we ignore this content. This is one problem. And the second problem is we do not only need to kind of employ key separation at the client side, but also at the server side. And we looked at the major server implementation. So in particular, we looked at Apache with mod SSL and Nginx, and it turned out that in Apache mod SSL, we were not even able to somehow configure the server in a way such that it uses different certificates for different protocol versions. And Nginx, this doesn't mean that it's impossible. It's just that we tried hard and we didn't find out how it could work. And I guess many other server operators could have the same problem. And for Nginx, it's the case that it's possible to configure only one single certificate. So yeah, so there are many different problems on client side, on server side, and on the protocol level, which makes it very difficult to employ key separation in practice. Next, please. Okay, so to summarize, I first would like to say that finally removing RSA PKCS1 version 1.5 from TLS is a very good decision. And it's a step in the right direction, but unfortunately, it is not sufficient to protect against all its weaknesses because TLS 1.3 will be used in coexistence with older protocol versions. So the main kind of take-home message that I would transport in this talk here is that I believe that key separation is extremely important. And that we should try to make it possible to use proper key separation somehow on the internet, for instance, by modifying X509 in a way such that key separation is possible. And of course, we should also talk to browser and server developers or talk them into enabling this. Yeah? The reason is that even though we have now understood Drown and are maybe able to fix Drown, at least in a large fraction of web servers on the internet, there will most likely be a Drown 2.0 attack or something else which kind of brings us all these problems with Bleismacher's attack back once again. Yes, so that's the end of my talk. Thanks for your attention, and I'm happy to take your questions if there are any.
Yeah, good.
Yeah, Paul Ouders. Just another question, but a quick comment. Not only browsers, but HSM vendors should really also look into this, because if you have an HSM for things like DNSSEC, where you're only signing data, you really want to mark the key to say never encrypt anything to avoid a whole class of attacks, and they don't seem to do that. Yeah. So if there's people in the room here who can talk to these vendors, please do.
Yeah, very good point. Yeah.
Rob Austin, just another quick comment. Adding an extension to X509 saying, only this is the the TLS 1.3 flag or something like that, adding extensions is not difficult. It's just a matter of specifying them. The hard part is getting everybody to use them, of course. But writing the spec for it would take an hour.
I think the other hard part is getting the CAs to issue 2 certificates at the same time, where now the usual thing is to get just 1 certificate, and you have to ask specially to get 2 at the same time for the same domain.
So maybe just one comment on the comments. I agree that it's completely difficult. I guess we should decide if we want to fix this problem or not. And I mean, if we want to fix it, then we have to do something about it. And I mean, if it's difficult, then we have to tackle this difficult problem somehow. So.
Perhaps proxy certs, if they were more widely available.
Victor, do you want to identify yourself?
Sorry, this is Victor Duchovny. Perhaps proxy certificates could be used. Get 1 certificate from the CA, issue a per protocol proxy cert, and off you go. Of course, it needs to be supported by the various systems, toolkits, clients, and so on.
Okay.
But it's possible in principle.
Okay, so I would like to discuss this offline with you because I'm not familiar with proxy certificates, with this concept. So.
Hey, hello, Berg. 2 options you haven't discussed were we could simply deprecate the RSE key exchange altogether. This kind of has been made more difficult because Google decided to deprecate Diffie-Hellman, which leaves us with less compatibility options. But it certainly is on the long-term a reasonable thing to do. What would also be possible with the key separation is if you would say you configure a server that does TLS 1.3 only with, let's say, ET 25519 and RSA only with older protocols. I'm not sure if going into that direction should,
yeah, I think these are 2 hacks which kind of prevent this particular example of attacks. But still, I mean, the problem or the root of the problem where this comes from is that we use the same key for different algorithms. And this is just one particular example.
But that's an RSA thing. I mean, that's only with RSA.
Oh, I'm not sure. I wouldn't agree.
At least the only
I think
key algorithm we use.
There are examples where, for example, using DSA keys for encryption stuff and settings where there are chosen ciphertext attacks or stuff like this. So I think that the root of the problem is that we should use different keys for different algorithms. That's the setting which is considered in theory, and I guess it's the only manageable setting because if we want to kind of analyze the possible interdependencies between different algorithms. So if you have 100 different algorithms, then we get 10,000 different combinations of algorithms. Nobody's able to analyze them all properly. And the simple solution is just to kind of use different keys for the different algorithms.
No other questions? So great. Thank you, Tibor. Good work. So Tom?
I do have slides.
Working? No?
It should pop up in a second.
There you go.
Okay, there we go.
This will cut off the...
My name is Tom Gallagher. I'm from NSA's Information Assurance Directorate. My goal today is to generate some discussion about port scanning of private networks from inside the browser. And I'm going to kind of frame this talk around the WebSocket protocol. Be aware that this does affect other protocols, but I chose to frame it around WebSockets, and you'll see why as we continue. Next slide, please. So just a quick overview. I'll give background about in-browser port scanning for those who aren't familiar with it. I'll talk about the existing mitigations for it and the weaknesses of those mitigations. And then finally, I'll propose a stronger solution that was submitted via internet draft shortly before the cutoff deadline. So just as a base assumption, I think we can all agree here that if there's an attacker that's on the internet, they should not have any visibility at all into a private network that's behind a properly configured firewall. If we don't all hold that basic assumption, then this discussion will go crazy places. So I just want to make sure we're on the same page there. So just as a reasonable kind of extension to that assumption, if there's a single device on a private network that's browsing to an attacker-controlled web server, then the attacker still shouldn't have any visibility into this private network just because there's a single device browsing to that server. Next slide, please. We're a little cut off here. The reality of the situation, though, is that once a single device on a private network browses to an attacker-controlled server, the attacker can leverage that connection to the browser and perform this port scanning so they can identify devices on the private network by their IP addresses, and they can also identify the services running on those devices by their port number. The way this works kind of as a high level is that JavaScript is allowed to make requests to arbitrary IP address and port combinations, and then it can time the response of those requests. Now, these are all considered cross-origin requests, so they are protected by the same origin policy, but the timing of the responses of those requests aren't protected at all by that policy. So an attacker can then infer, hey, I got a quick response from this request, so there must have been something actually responding at that port, or it took a very long time to get a response, so there must have actually been a timeout that occurred there. Next slide, please. So looking at this at a little more detailed level, this is some JavaScript code that will actually do some port scanning. It just iterates over that small array of port numbers at a very one specific IP address. If you were to run this like I did, I ran it on a small test network, and the results are down there at the left. It's very clear that ports 80, 445, and 1234 were all responding because there's a very short period of time that the response occurred. Even though I can't tell what the response was because of the same origin policy, I know there's a service responding at those port numbers for that IP address within the private network. So like I said, this is a known technique. Browsers do try to mitigate this to some extent, and there's two strategies that are used to mitigate it: blocking and throttling. On one hand, blocking is this way of identifying what are sensitive ports and then saying that there can be no outgoing traffic to those ports at all. And throttling, on the other hand, it just kind of reduces the speed by limiting the open connection, the number of open connections that are possible, which makes doing any kind of scanning of a wide range of ports kind of infeasibly slow. Yes, there's a question.
Alex Meyerhofer, I'm just wondering if an attacker could prepare a zone where he would include like all the private IP addresses that he's suspecting that the attacked entity has on the inside in his own zone, yeah? Would he then be able to circumvent the same origin policy? You know what I mean? I'm attacking from www.example.com, and I prepare in my zone a series of subdomains that all include all RFC 1918 addresses. I synthesize them. And then I try a WebSocket on those host names rather than the IP addresses.
So you're talking about host names, not IP addresses? Is that what you're saying?
Yeah. I'm not an expert in the same origin policy, but
okay. So, so the same origin policy, it doesn't protect the timing of the responses, which is the issue here.
Yeah.
The content of all those responses is very well protected by the same origin policy, so you're not going to break it in that sense. I'm not quite sure what you're saying.
I'm saying as an attacker, I prepare a zone file that on my server that includes all the RFC 1918 addresses for host names. Yeah.
Okay.
And then I use on the client, on the attacked entity, I use those prepared host names to scan through in the same zone from which the original attack came from. Yeah. Would that allow me to circumvent the same origin policy and even go farther than what you're describing?
That's an interesting concept. I'm not sure how that would play out in reality.
Yeah, briefly, no, because subdomains are different origins. So
Richard?
I'm Richard Barnes from Mozilla. So, say which part of that?
Richard, we couldn't hear you at all.
Yes, so briefly, that attack doesn't quite work as stated because the subdomains in the zone would be different origins from the starting origin. But
face the mic.
Binding stuff, you might be able to do something like that.
So Richard, the noise doesn't come out of the back of your head?
Doesn't work as stated, but might be you might be able to tweak it to work.
Okay, so moving on then, mentioned we have blocking and throttling in browsers as far as mitigation for port scanning. There are a lot of limitations to those mitigations though. On one hand, you have blocking. It's essentially a blacklisting type of strategy. You don't have a whole lot of consistency amongst the major browser vendors. Looking at the major browser vendors, there's about 60 different port numbers that are considered sensitive that are blocked from this type of strategy. But only 6 of those 60 are actually consistently blocked among all major browser vendors. So there's not a whole lot of consistency there. It's also hard to be confident about adding additional port numbers to be blocked, because it's hard to predict what's going to need to be connected to a browser at some point in the future. So you can't really be confident about that. Throttling, on the other hand, it does a pretty good job of making port scanning inefficient. If you were to throttle it so you could just do one IP address port number per second, it would still take you about 208 days to map out the entire private IP space, which most attackers probably aren't willing to do. But realistically, attacker doesn't need to map out the entire private IP space. They just need to find where your devices are on the network. And because devices are usually clustered and are done around known IP addresses or typical IP addresses, attackers can just map out a very fractional part of the private IP space to identify start and endpoints of when the devices are. And once they do that, they can just enumerate what ports for each of those devices. And attackers might be very determined to do this kind of campaign. They could space this out over multiple sessions, multiple users, and take months to do it, because network architecture doesn't change very frequently. So for them to have mapped out your network and to know what kind of services you're running and where they're running could be very valuable for them. And then the last issue that I have with throttling is this WebSocket technique, which I alluded to earlier, and I'm going to talk about more on the next slide. So with the advent of HTML5, there's 2 new capabilities that came into being, and they both affect this in-browser port scanning. On one hand, you have web workers, which are these child processes that can be spawned from JavaScript. And on the other hand, you have WebSockets, which is just this communication protocol that can be used from within JavaScript. So the issue here is that most browsers will actually place the throttling limit on each browser process. But now JavaScript can create its own processes. So if a browser thinks it's limiting you to, say, 10 open connections at a time, but you can create 256 web workers, you actually have an effective scanning space of 2,570 different open connections you can have at a time. So ports that you can be scanning simultaneously. Next slide, please. So because of these kind of limitations to the current mitigations, I feel like there needs to be a stronger mitigation in place here. And this is kind of the solution that I came up with. It's pretty straightforward. Right now, the only way that port scanning works is by looking at the difference in timing between the responses of two different requests. So if instead we made this a fixed latency for WebSockets, when that opening handshake fails, just at a fixed latency is when you report the error back to the JavaScript environment. Then there'd be no way to distinguish this opening handshake failed because I wasn't talking to a WebSocket server, or this opening handshake failed because I wasn't talking to anything. There was nothing there to respond to me. So if we had that fixed latency, then there'd be no way to tell anymore. Go to the next slide. So obviously there's a disadvantage to this. If we're talking about fixing the latency, we're talking about increasing the latency overall. You'd have to take the error condition where you're talking to a non-WebSocket server and you'd be holding that error until the timeout latency occurred. But I really don't think this is a huge impact, because we're talking about increasing latency for web applications that are already having errors. They're having errors connecting to their WebSocket server. You're not talking about increasing latency for a web application that's totally functioning normally. And if you can't talk to your WebSocket server anyway, then it doesn't really seem as big a deal to be increasing the latency to which you don't know you can't talk to your WebSocket server. So I don't think there could be some fringe cases where that does impact regular usage, but I don't foresee those. I think it's a worthy sacrifice to increase the security here. Next slide, please. The benefit of doing the strategy, if we revisit the code from earlier, on the left side you see that was the code the results pre-mitigation. You can clearly tell, again, port 80, 445, and 1234. They all responded very quickly. After the mitigation, the response times are too similar because they're all held to some fixed latency. Now, it could be off a little bit based on when the browser actually gets around to reporting the error back to JavaScript. But in general, there's no distinction between what was responding, what wasn't responding. So what's next? That question mark really is a question mark in my mind because I don't know. I'm new to the IETF. This is actually my first meeting. So I did submit an internet draft. Where it goes from there, I'm not sure. In the end, it would be great if browser vendors could consider adopting this strategy and incorporating it to kind of protect the end user more from this type of behavior. And in general, if the individuals in this room and other members of the security area advisory group would kind of more strongly consider this issue of in-browser port scanning when you're doing reviews of different protocols that are going to be used in browsers, just if there are security considerations that are added, or maybe some guidance to implementers who could be adding this to different browsers. Next slide, please. That's all I have. If there's any questions, I'll take them now. Otherwise, I just want to say thank you to Stephen and Kathleen for letting me speak here, and it's been a privilege to talk with everybody.
Fleming Andreas, just one comment on one of your assumptions. You said that you didn't think that it was going to be an issue to increase the latency on an error. There is a use case scenario that we have today, which we refer to as connectivity checking, where there's a number of candidate addresses that we're trying to figure out which one actually works. That could be a scenario where it might actually have an impact because you're just trying to successfully go through the list to figure one out that actually does work for you. So I don't know if you've considered that, but that might be something to look at.
Now, are you trying to connect to things that are WebSocket servers already in that case?
That's not the primary use case today, but it certainly could be.
Okay, because if it is something where what would be increasing is the latency for the error case where you're connecting to something that isn't actually a WebSocket server. If you're looking at something where you're trying to connect to something that was supposed to work and just times out, that latency is actually going to stay about the same. But that is an interesting fringe case that I hadn't considered.
Pat McManus, I work on the network stack for Firefox. So thank you. This is really fun. Pat McManus, I work on Firefox. Thanks for doing this. I have another room where you got to get right up close to the mic, and that really distracts me. So thank you. This is really useful. So we, I can't speak for the other browsers, we actually do rate limit the WebSocket stuff globally, so you won't get the worker bonus on our platform, although I'm with you, I don't think that's really going to be the limiting factor for most attackers. With respect to like essentially slowing down and creating fixed delays on error conditions, that's a little tricky because there are positive use cases for those things. This is how failover is done, hunt groups and all kinds of other things, and you will damage applications by doing that, so there is some pushback when those kinds of implementations happen. We do not rate limit errors or connection rates or anything like that at all on XHR, which is really probably the much larger vulnerability here, and I don't know of anyone who does. And I'll leave it there rather than pointing out another vulnerability.
Okay.
Victor Duchovny, if I remember stating my name. So might it not be better to teach the browser the boundaries of the internal and external network somehow, and not allow external origins to refer to an internal resource period, and do that instead?
So I think we'll cut the line after Richard.
So I think that's a really good point. I don't think you can totally say that an external couldn't connect to an internal, because I think there's use cases where that would be beneficial. I'm not really a big fan of like warning prompts. but that could be some sort of application where, hey, your browser is about to connect to a local IP address. Do you want that to happen? I'm not sure how difficult that'd be or what impact it would have on the user.
So Richard Barnes from Mozilla again. Yeah, Victor, there has been some discussion about doing something like cores for stuff that is going from, say an externally loaded page trying to talk to some internal services. There's a couple of challenges with that. One is that you have got a bunch of existing legacy stuff that might break. Whenever we tried in Firefox a year or so ago, just like disallowing that sort of thing, and got like huge complaints and we weren't able to ship it. So there's issues of that sort. It also turns out to be non-trivial to distinguish when you're talking to an internal thing. I'm sure you're familiar with these DoD networks that use publicly routable IP addresses for internal networks. There's that sort of issue. There's large enterprise networks that kind of look like NATs that create the appearance of things being private address based when they're actually talking as the public internet. So some issues of that character. But the W3C Web AppSec group is having some ongoing discussion about this. There is interest in finding some sort of solution, and that may ultimately be the more productive path to having some like explicit internal-external separation. So I'll chat with you afterward. And we can. I think that would probably be a good group to talk about this sort of stuff with. So I'll get you hooked up with them later.
Okay, great, thanks.
Great.
Right.
Thank you, Tom. So next up is Vasily. So Vasily, I did note that you have 24 slides and 10 minutes.
Okay, I will say about that. Hello, everybody. I'm Vasily Dolmatov, and I was assigned by the study group 17 of ITU standardization sector to make a presentation here for the information of the people what work are in progress in the study group 17, and maybe consider some collaboration or cooperation or use of information which will be presented or prepared in this study group. Next slide, please. I will have I have a deck of slides which I will browse very quickly, just pointing at some things which I would like to stress upon. Next slide, please. The structure of study group 17 is highly resembling the same of the IETF. The equivalent of working groups are so-called questions, which are nearly equally procedurally chartered. Next slide, please. So they formed in the working parties. Next slide, please. So the main thing which I would like to point at that slide is there are a lot of coordination between different standard bodies in study group 17. I left only one slide on this topic, and this topic I will tell about later. Next slide, please. So, and then just a few words about working groups, and I will point to the documents which are on the development now, which could be of interest for IETF people. Here in the question 2, I would like to point out to the XSDNSEC2 document for the security of software-defined networks. Next slide, please. Here, in the question 3, well, I would like not to point any topic. Next slide, please. And the slide question 4, it is interesting work called x.nessa, which is for the communication protocols and requirements for the information of the incidents between networks. It can be of some interest for the IETF people. Next slide, please. Here, so again, I will skip it. Next slide, please. So here in the cloud computing, there are several things which could be interesting. So for instance, XCSC data sec. So next slide, please. For question 10, it's very broad question and very interesting one with a huge cooperation between ITU and our standardizing body. It's concerned with identity management. The problem is, which is arising quite high now with the Internet of Things development and other things which are connected to the security of applications and all other real things. Next. So there are several interesting works in the question 6. I would point to IETF96-1, IETF96-2 concerning the Internet of Things security, ITS-SEC1 and ITS-SEC2 concerning with intelligent transport systems. So again, SDN-SEC1, which is another document connected with SDN security and which is developed in this working group. Next slide, please. Here, several documents concerned web security, which could be of interest, all of them. Next slide. Here, I would like to point out the series of the XTH. Maybe it will be interesting as an application, but I really cannot see real connection between IETF work here. Next slide, please. So you know all of this stuff which is under the development in the Q11. It's X509, it's ASN.1, that's OID. Next slide. So now there develops new revisions of all of these documents, and again, it can be communicated with and can be made some propositions for these revised documents. Next slide, please. So this again, one of the documents is XOID IoT for about the possible usage OID methods for the IoT identification. Next slide, please. So this is question 12. Mostly the formal description languages for the testing or something like that. It could be of some interest for the groups which are trying to describe such processes and to have some frameworks or use cases for that. Next slide. It's a continuation of the documents which are now developed in the question 12. Next slide. So here will be 2 slides just to mention our other study groups of the standardization sectors, in which study group 17 is working with a close cooperation on the security issues. You can see half of the list here. Next slide. And here I would point to the specific study group 15 and study group 20, a new study group which was formed for Internet of Things and is now starting its works in that direction. Next slide. So just several links for those who want to understand it more precisely and to learn it more thoroughly. Next slide. And I can be the contact for all the questions which are concerning study group 17 and cooperation and collaboration with its works. Thank you.
Thanks. Yes, very good.
Thank you.
Paul.
This is actually for the ADs. Are you going to upload these slides? Because there were a couple of things in the middle that scared the bejesus out of me. I didn't know that they had opened up some new things. So actually having these would be really.
Yeah, I was in the process of doing that when the network started being funny. So they will be uploaded to
wait till
later.
it's not funny, because some of these aren't.
Yeah.
So for those of us who've been in the PKIX world, we're used to having to see some of these and know which ones we're looking for. So yeah. Some of those shouldn't have been there, I hope. So please do get them up.
Yeah, so I think the good news is that if you have issues with that you'd like to talk about some of the work going on in IT, then Vasily is the person. He's coming here for not just this reason, but I think you're planning to be at IETF meetings for the next while?
Definitely, I'm the IETF participant. That was one of the reasons why I was assigned to do this job, because I know IETF.
And so, for example, we had some contact about this particular document, the XCMS one. There's a bunch of liaisons we sent, and so.
So yes, it's under development now.
Okay.
In this case.
Good. Any other questions? Okay. Thanks, Wesley.
So this is not actually a question for him, but there does seem to be a problem with the 5 gig range in here. So if some people, not everybody, want to switch to the 2.4 only, you might get better service.
Hannah's next.
I've actually gone back and forth and I get disconnected on both.
Okay. So the knock no, and are trying to sort it out. So Hannah.
Thank you.
Hello. Yeah, I'll talk about a little research we did on the security of GCM ciphers. First of all, I have to excuse Aaron. He couldn't be here today. Originally wanted to do this together. Can you? So I read this blog post from Adam Langley somewhere in December, I think, where he pointed out that there's a potential problem with AES GCM in TLS, and that specifically that it needs an 8-byte nonce value, and nonce is abbreviation for number used once. And Adam Langley here says that the only secure way to do this is to use a counter, and if you use a random nonce, that may be risky. And that he checked the top 200,000 implementations and found none that got this wrong. And I thought there's I have this idea that if there's something you can get wrong in a TLS implementation, then someone will get it wrong. So I looked further. Next slide. Yeah, so specifically in GCM, if you have a nonce that's, if you use the same nonce 2 times with the same key, then you have 2 potential attacks. One is relatively straightforward, that by XORing the 2, you get the XORing of the plain text, which leaks some information, and if you know something about the data, you may decrypt something. And the other one is an attack from Antoine Drew. He mentioned this attack in a comment on the GCM standardization process, that you can extract the authentication key of the GCM mode. Yeah, and so now what TLS does is we have 4 bytes that are kind of given by the algorithm, or by the and 8 bytes that the implementer has to choose. And the easy way to do this that's secure is to just use a counter. So you could start with 0 and use 1, and because it's 64 bits, and that if you go to the full 64 bits, that's not likely that you will repeat a nonce. You could choose them at random, and that, as earlier Adam Langley said, and yeah, that this is risky if you encrypt large amounts of data. I tried to get some numbers on how large they really have to be. You're really going into the area of terabytes, but there may be situations where this happens, or at least where you get to a risk that's so high that you find it unacceptable. And then you can just, of course, repeat your nonces all the time, like always sending the same value for the nonce, which is completely broken. And next slide. And this is the RC, TLS 1.2. And I think this is really a problematic spec, because it tells the implementer, okay, each value of the nonce explicit must be distinct for each distinct invocation of the GCM encryption. So it tells the implementer what he needs to achieve, but he doesn't tell how to do it. So what I had on the slide before, just use a counter and then everything's safe, that's not written in the standard. The standard just says you have to choose distinct nonces, but gives no guidance how to do that properly. Yeah, so I think this is an example of how specs shouldn't be written. They should be more explicit or should avoid such pitfalls.
Kenny Patterson, can you go back one slide, please?
Yeah.
What does the last sentence say? Could you read that out?
Yeah, okay, the non-explicit, maybe the 64-bit sequence number. Yeah, that's...
I think that's quite useful advice, no?
Yeah, we could have made it a must, but you're right that there's some guidance, but yeah. Yeah. Okay, you have a point. Okay, next slide. We did an internet-wide scan and we found a small number of hosts with repeating nonces. I spent a lot of time trying to track them down and find out which devices they were. I found out that a couple of them were from Redware and some of them from, that's not disclosed yet, but they were used by Visa. Visa only reacted after Ars Technica reported about this, before they ignored my emails. And we found around 70,000 hosts with random nonces, and that large part of them were from IBM and from A10. But I assume there are more implementations that we were unable to identify. Yeah, sorry, I had a slide for the affected devices. So, next slide. The spec for TLS 1.3 and also for the Cha-Cha-20 cipher, they are more explicit in how you generate that nonce, and it's not sent over the wire, which essentially means if you get this wrong, then your implementation won't be able to speak with other implementations, so you will immediately notice. Yeah. Slide. Then there's kind of the bigger debate of if on the base of an algorithm level these issues can be avoided, which is under there's the idea of having a synthetic IV, which kind of that you have an initialization vector that you're not setting in the implementation, but that kind of gets generated out of the algorithm. And there's currently some debate about standardizing ASGCM as IV. I think there's some disagreement on what exactly nonce misuse resistance means, and but yeah, there's development in that direction. Even on the algorithm level itself, these issues could be avoided. Next slide. Yeah, so my conclusions would be, okay, specs should, if possible, avoid such pitfalls for implementers, which in this case was possible. As we see now, the TLS 1.3 has kind of fixed that. And if it's not possible, then I think the spec should be as explicit as possible on how to avoid such security issues. Yeah, and I'd say GCM in TLS 1.2 fails in both regards. Yeah. And what I'd also like to add, which is not on the slides, is that we need better testing for this, because this is a mistake that obviously can happen, and it's relatively trivial also to test for that, and nobody has done that before. And what I'd like to see is for all these kinds of issues that are testable, that we have something like a TLS test tool run on this server, and it will tell me all the things that could go wrong and if the server did it right. Like we had other things like people forgetting MAC checks or forgetting padding checks, or these version intolerance issues that we had a long debate in the TLS working group, and all these kinds of things. So for robustness of our implementations, I think we need better testing. Yeah. I think I was much shorter than...
Yes, good.
Thank you.
Any questions or comments?
Fernando Gont. A question is if we author a document that was later split in a few documents, and the question is if you have looked at it, because this essentially...
Sorry, I didn't understand it. Can you repeat?
Yeah, we author a document on the generation of IDs, which is essentially this. I mean, we were not talking about nonsense specifically, but it's the same topic. So my question is if you had looked at it, because as far as I can see, it's like there's like the part of the advice that we have in our document, like answer some of these questions.
Okay, so you say there's a document on how to generate IVs?
Yes, not specifically for TLS, because it's a problem at the last.
Is it a draft or an
Yeah.
RFC or?
Yeah.
Okay, I didn't know that.
So at the last SAAG meeting, we presented it and we gave examples that, I mean, this is just yet another example of IDs that are generated in an improper way. At some point that happened for port numbers, TCP ISNs, fragmentation IDs, and so on. So in this case, you have a particular problem, a particular security problem, but at the end of the day, it boils down to the same thing, IDs being generated in the wrong way.
Yeah, okay, so I'll definitely have a look at that.
Okay.
Okay. Thanks.
Okay. Thanks.
Joe. Where are you? Yep.
Hi, everyone. So my name is Joe Hall. I'm here to talk about our draft, the Survey of Worldwide Censorship Techniques. Next slide. So just to, hopefully Mideko can follow me a little, I can't see. So in IETF 91, I came and presented a very rough draft of basically a descriptive document that talked about all the ways that global censors were messing with protocols across layers. Really, the motivation here is to provide sort of a reference document for protocol designers that if you care about resilience to this kind of an attack, a censorship kind of a attack, you might learn something about how to make your protocols more resistant to those kinds of things. Since that time, we've had a ton of really good feedback. We've worked through a series of issues. If you pull up on the slides, you can actually click on the link and look at the things we've worked through. Particular thanks to Stefan and Martin for adding a whole bunch of stuff to the document, or asking me to add a whole bunch. Since this time, in March of this year, 7554 came out, which is an IAB stream document on technical considerations and filtering and blocking. That's about sort of information architecture and seems to be aimed towards network operators who are considering employing filtering and blocking. Ours is for protocol engineers who might care about resistance to censorship activity on the network. Next slide. So just a quick overview of some of the changes we made. When I presented it, I said there's sort of three elements of any sort of censorship activity, and I called them aggregation, identification, and prevention. This is sort of from a set of literature that talks about this kind of stuff. That was very confusing to everyone, and so since then, we've added other authors, Nick Feimster's group at Princeton, and we've sort of come up with prescription, identification, and interference. Prescription is deciding what you want to block. Identification is during the network interaction, classifying traffic that you want to block via some sort of technique that we describe. And then interference is making a decision to block or to rate limit or impair or something like that, the traffic that you've identified. We've added a whole bunch of different points of control that censors may seek to interfere with in a variety of ways, including certificate authorities, these new network features like content distribution networks, and services themselves, which we're starting to see, like WhatsApp in Brazil 3 times now, even though the higher level judges immediately say that that's a disproportionate activity. We also removed a pretty problematic statement where we had used as an example just the tld.ch, just for whatever reason I don't remember, but we didn't mean to imply that Switzerland actually censors anything. And so we just changed it to something like .fu or something like that. And there's the DNS interference section was just horrible. We had used this sort of DNS cache poisoning as the only sort of technique of interference, when in fact, I didn't know this, but apparently that's never been observed in the wild, and it's actually sort of this race condition where a censor is trying to reply to a query from a cache before the authoritative resolver can actually do that. So we have added things we actually do see, like mangling, and they're actually in the draft. If you open it up, there's something that Stefan pointed out. If you send a packet to an unallocated IP in China with IETF.org in it, you get no response. But if you put a blocked or censored domain like Facebook.com, you get a meaningless nonsense IP address back. And then there's lying, which is where a censor may specifically tell an operator of a recursive resolver you're not allowed to check the authoritative for these kinds of endpoints. You need to go this place. Next slide. So what next? I think we're getting to a point where it's pretty. I've done as much as I think of. I can think of to do there. If you're interested in blocking and current examples that might be useful to network engineers to look at about what happens on the network, please read it and let me know if we've left anything out or if we're not being precise enough in places. One big to do is that it seems like both in the three sections of sort of the types of the sort of flow that a sensor would take to censor stuff, we're going to actually break it up into layers because it just makes more sense. We've done that with the identification piece, but it's not yet done with the interference piece. It's just some refactoring that takes time. One question I have for folks, it's you know, we saw this with the attempted coup in Turkey where some of this stuff is evolving right now, and so the document in a sense needs to learn about that stuff over time to really be helpful. And you know, when the coup was happening, we were sitting there watching a whole bunch of different types of techniques. We saw DNS filtering happening. We saw route misannouncements as well to block stuff across different ISPs all at the same time. It's totally unclear to me, you know, if they were all ordered to do that, if they just thought that was probably a pretty good idea given what was going on or what. I have no idea how to tell what was happening there. We have gotten in IRTF in the Human Rights Protocol Considerations group, I thought about, you know, putting this document into there as sort of a descriptive reference document that might be useful. But we got some feedback that it would benefit from the IETF process, from actually having folks look at it, having a call. And so that's why I'd like to consider getting security AD sponsorship from one of our wonderful security ADs. And I'd like this, as I said in Honolulu, if you were there, I'd like this to be the first of a stream of documents that might be helpful in you all to designing your protocols. So for example, traffic analysis. I know that's a huge subject that is not nearly as sort of as easy and tractable as, you know, blocking and filtering and those kinds of things, or censorship may be. But I think it would be helpful because a lot of us, there's people amongst us that know quite a bit about traffic analysis. There's people that have no clue about it, and it may be helpful to have something lying around that can be useful to people who are designing protocols that might want to refer to it or otherwise learn from it. I think that's it. Yeah.
Okay, so any comments, questions? Okay, so how many people think this, or how many people have read this document? Okay, one. One. And how many people think a document like this might be useful as an informational RFC?
That's pretty
Loads,
good.
okay. All right, so I guess I'd encourage you to go read the document, give Joe your feedback, and I guess we'll have a look at it ourselves again. I haven't seen it since way back when, and then we'll see if we, you know, progress it as an informational RFC.
Thank you.
Thanks. And Jove or Magnus?
Oh. Hi, Jovnir. So this is about writing a replacement document for RFC 3552, and there is no 00 draft. That's Stephen and Kathleen asked me and Magnus to write this, and the only way you can get a slot without 00 draft is if the ADs ask you. So next slide. Okay, so RFC 3552 was published in July of 2003, that's 13 years ago, and as an IAB document. It follows RFC 2223, which required every RFC to have a security considerations. So this is kind of instructions of how to do that. It has extensive sections about the goals of security, of the internet threat model, and it has a very extensive section, like 13 pages of common issues, both in security requirements and in security solutions. And pretty much that is why we need a new RFC, because that section is kind of outdated. The common issues are no longer common. There are different issues. So next slide. So there's some outdated information, the mention of protocols, algorithms. Our concept of privacy has evolved, in part by publishing a new RFC, but in general. There are changes in the internet environment from what it was in 2003. There's pervasive monitoring, just as an example. Now, we are considering adding draft GAUNT numeric IDs, SEC considerations into this. It's not decided yet. It's up to the list. And perhaps adding something about opportunistic security. Some special cases that we think need to be handled is extension documents. There's lots of documents that extend some existing protocol, and then you get the security consideration that says, oh, the master document, then it's all in there. Yeah, it's fine. And sometimes that's okay, sometimes it's not. And we want to have guidance about when it is okay and when it is not. And also there are some usage documents for specific applications of generalized frameworks that we think needs some text about that. So next slide. Okay, so example of outdated information. Section 452 recommends using SSL or TLS 1.0. SNI is described there as something that is too new to have seen wide deployment. One section before that recommends using AH, where AH is pretty much pulled out of most IPsec stacks by now. It also states that both AH and DSP are mandatory for IPv6, and that has been relaxed for IoT at least. Well, it has been relaxed in general because of the needs of IoT. There's no mention of algorithm selection, no mention of algorithm agility, no mention of AADs. There is quite a bit of mention of non-repudiation that most of us have decided that is not really a meaningful concept. And there's an example of making secure purchases over S-MIME. I don't think that's taken off so well. And there's something, section 3.2.2 on password sniffing. It mentions protocols such as Telnet, POP, and NTP, but no mention of HTTP or OAuth. Both are pretty much vulnerable to this. So next slide. Okay, so privacy is most of this is most of what we need is just referencing RFC 6973. Some issues that were not considered at the time, but now we think are important is the compromise of stored data, correlation between different streams, different protocols, even identification, secondary use, anonymity versus pseudonymity, and data minimization. All of these are covered very well in RFC 6973, and we need to at least mention them and reference the appropriate sections. So next slide. So changes in environment. Well, we've all talked a lot about pervasive monitoring, and RFC 3552 distinguishes off-path and on-path attacks. There is also a distinction between passive and active attacks. And although it's not stated explicitly, it's assumed that on-path attackers can do either passive or active at will. What we've seen with pervasive monitoring is that the pervasive monitor can do very large-scale passive, although it is on path. So does this matter? Well, it matters for some protocols, it doesn't matter for some. We should have some text describing when to talk about it and what you have to say. So other changes in the environment is what is referred to as the depth of the perimeter. Familiar with the term? It's the fact that this corporate laptop that Kathleen has there is meant to be.
Oh. Sorry.
So you don't connect it at work?
No, not this one.
Okay, so the phones we all have here are going to go onto the corporate Wi-Fi network sometime next week, probably. Okay, so whatever malware they pick up here, they're going to bring to the place behind the firewall. And there's a lot of UDP-based protocols that we didn't have in 2003, and DTLS that also wasn't available in 2003. Okay, so next slide. So the plan, we want to submit a 0.0 draft by September, probably a lot earlier, probably very early August. That will be just the 3552, changing the author names and doing whatever is necessary to get it past IDNets. Then we hope to have an extensive discussion on the SAAG mailing list and publish 2 or 3 revisions by SOL. And we need to revise the examples, make them more modern, and have more discussions at IETF 97. Hopefully, IETF last call early next year. So, like it says there, comments are silver, text is gold. So, please send it to us. And next slide. Yeah. So one thing. For now, the discussion is going to happen on the SAAG list. If we see that the volume is very great, then we might want a mailing list all on our own. Yes, Barry.
This is Barry Leba. There we go. In the area formerly known as app, we have a list of app issues that people need to consider on a wiki page. Now, that's turned out to be a useful thing to point people to. And I suggest, not as an alternative to doing this kind of update periodically, but that this document points at a wiki page in the security area that has hot issues, things that have changed since the last version of this BCP. Put the pointer in the document, and then as things develop, you can start listing them there while you're preparing the next revision so that people are alerted to it.
That's a good idea. Thank you.
Paul Hoffman, this is actually a question for the ADs. I have proposed before and gotten some positive response and negative response on the idea of that musts and shoulds should not appear in the security considerations unless they are duplicates of stuff before and maybe not. Should I start this before the 0.0 or should we wait for the 0.0? I don't want to get it in too late because a lot of people agreed with me, but a lot of people didn't. When would you like that to come up?
Send them out to the list, I think.
Okay, before the 0.0.
I'm one of the people who disagree with you.
Yeah, exactly. So that's why I was asking. So do it before the 0.0?
I think so, yeah.
Okay, great, will do.
Thanks.
Rich Sauls, just want to say thanks. This is way overdue.
Wendy, good.
Yeah, Wendy Seltzer, W3C, thanks, and look forward to coordinating the pieces that we can bring up to the considerations in the web security reviews.
So could we get a bunch of people to agree to have a read of this and a reread of this and give comments?
Great, thank you.
Great. So, and as you heard, the authors are planning on putting a 0.0 out by, when did you say?
Early August.
Early August. So if this week is a good time if you get a chance. But sooner is better for anything. So if you have any issues, then raise them, please. One kind of caveat: I would love if this came out much shorter, because I think that'd be more useful. But
I think that's a great goal, but we have to do the right thing here.
But yeah,
have some tricks up.
Yeah.
We might have some tricks up our sleeves how we can make this shorter, but let's take that on the list when we started restructuring the document or fixing things.
Great. Okay. And thanks again for being willing to do this. I think it's very useful.
Yes, thank you.
Okay. So I think that brings us to open mic.
Yep.
Okay. The floor is yours. So there were a couple of people who had asked for presentation time, and we thought we didn't have it. And they said they would go to the mic just to say their thing, but I guess they changed their mind.
I was trying to get Leif to answer his jabber so he would do this instead of me. All I wanted to do at Open Mic was to mention the Cryptech workshop that we'd had and have people take a quick look at the website and the
Yeah,
I can't,
That mic is
I-
particularly tough. I don't know.
I can't get much closer. Okay. What I wanted to do was mention the Cryptech workshop. The easiest thing to do is to go to cryptech.is and then at the there'll be a link there to the Berlin workshop, and then there's a wiki that has 4 presentations and some additional details there. And if you have any thoughts, comments, or want to contribute to the project technically, that would be great.
Where's the blue sheets? We have one here. Just one.
Just one.
There's one blue sheet somewhere over here. And we stole it again. Okay, any other Vikings?
Matt Miller, just wanted to let everybody know that right after the next session, we are having the ledger BOF. This is about a distributed web payments ledger. This is work that's a group from Ripple and originated in W3C community are bringing to the IETF to see what they think. So if you have interest or comments or questions, please join us in Potsdam 1 right after this.
Hi, this is Victor Duchovny. I'm monitoring Dane deployment these days, and I noticed that many folks are still running rather obsolete DNSSEC servers that historically have been adequate. They return correct answers for valid data, but they rather fail badly at denial of existence. And this is important for Dane and email because bad denial of existence looks like a man-in-the-middle attack downgrading the non-existence of your TLSA records and the like. So it will start to cause email delivery problems for the few and the brave who are starting to implement Dane. So please make sure that your DNS servers are reasonably current and aren't 10 or so years old and running old specs or buggy and the like. That's all.
Here on Chef, a quick advertisement. We just republished the RFC on running code, the implementation status section as a BCP. It's RFC 7942, and please use it in your internet draft. So if you have an implementation or implementations, please document them for the benefit of the working groups.
Okay. Actually, one thing I forgot to say is, I think I can't remember if I said it last time, but I won't be re-upping as AD. So there will be a vacancy in March. And is Lucy still here? No. So if give NomCom your feedback, volunteer, and so on. Lucy is there. So Lucy's at the back, and so she'll be hiring some new victim. Okay. Anything else, or I think we're set. Thank you.
So it might be something with the presentation. I'm at 9% and it's not moving.
Yeah, the network is, I don't know what's wrong.
Yeah, maybe the network too. Yeah. So I can't be reached.
No, so I put the ITU guys presentation on my web server, but it took like 10 minutes to upload. Like all the time that your screen's on, so it was uploading the file.
Wow. All right. So I'll try again later.
Yeah.
So, how are you? I'm totally packed today. How about you?
Not too bad. I've got a thing to go. I was going to go to the leisure bath. But let me just try and find the blue sheet. You're there for a minute, yeah?
Yeah. I can hang out for a few minutes.
How would you like? You want to just talk now, or do you?
Oh, right. No, now is actually very good.
Yeah. So I mean, here is my two best if it's an issue.
Let me just ask Stephen one more thing.
Okay.
I may have to leave Route X at 7.
There.
That's what I think.